no one uses calculators until very last hour. It's like you only keep calculator?
Huh?
Or do you keep math stuff?
Huh? All right, now we're ready to go. Okay, we are not writing this down yet. I'll tell you when to start writing down. We're going to do a quick review over function that we've already talked about in life. I'm talking, I don't know what anybody else is. Okay, that first one right there. F of x, which normally we put a what instead of f of x? A y equals mx plus v. What kind of function or line does that make right there? That right there. What kind of line function does that make? Perfectly straight. Does it bend? Goes on and off forever. Straight sideways, straight up and down, negative slope, positive slope, whatever, right? What does the m represent every single time when it looks like that? Slope. The number in front of x is the slope. And that b represents what? Y-intercept. We've learned it. We're good at it. Blah, 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 and so on and so forth. Yeah? Okay, in a table, it looks something like this. Say I picked -2. Well, how would I figure out what this y was? How did I figure out this y was -3? Where did I plug in this -2 right here? What does that -2 represent? X. So where do you think I plugged it into this function? The x. So I did 2 times the -2, which is -4, and -4 plus 1 popped out a what? Negative what? Popped out a -3. When I plugged in a -1, I plugged the -1 into this x, and what popped out? -1, so on and so forth. Yes? Okay. We haven't done a whole lot of that popping in this year. Last year, you did a whole bunch of that, creating tables and stuff. Okay. We haven't done it this year, but here in a minute when we do exponential functions, we have to create tables to do this because it makes it, well, you basically have to get it able to figure it out. Okay. Now, a couple things though also with these tables. If you'll notice, tables are kind of important when we're dealing with exponentials. That's kind of why we're kind of reviewing this stuff. How do we look? How do we figure out? Well, obviously, what's the slope of this function here? Is it the 2 or is it the 1? It's the 2. Okay. By looking at this table right here, how can I figure out that the slope's 2? Anybody remember how I figured that out? Yes, exactly right. She said y over x. She's saying y is changing by how much over here? Each one of those is changing by what? 2. Okay, and the x over here is just changing by what? 1. So she said, okay, the slope is 2 over 1. So did we actually have to look at this to know that this table is slopes 2 over 1? No. Okay, boom. How can we find the y-intercept from that table? She said where x is 0. Where x is 0, what is the y-intercept? 1. So do we have to actually look at the function to know where the y-intercept is? No. Same rules apply. All's the same. Everything's a good. Key right there is, how did we find the slope? See how much is changing by. Yes, that's going to be helpful later on in life. Okay. Second equation. All right. Second equation was one that looked like this, or the second function, I guess I should say. We've done our problems that look like this. What kind of function is that? It is a v. Well, what do we call that? Absolute value. Good. How do you know it's a v? Because it has absolute value. Okay. It was a little bit different, or they had a little bit different letters to represent different stuff with the absolute value. What does that a represent, though? That number in front of our deal, what did we say that always was? The slope. What did that number inside the absolute value tell us? Moved left or right. Good. And the h back there told us what? Up or down. So based on where the numbers are, it doesn't matter if it's the straight line function, okay, or an absolute value. Wherever the numbers are, it tells us how to graph that or how to move that graph. Yes? Kind of with me on that? Okay. We should be able to graph it based on that stuff. Now, I went ahead and made a table of this one. Okay. Now, if I found the slope, it's pretty easy. We do it just like we did a while ago. What is the y's changing by over here? Well, they're going by 2. Sometimes they're going by -2. Sometimes they're going by +2, right? They switch up. So if they switch up in your mind, say you didn't even, yeah, well, I can scribble this out. Say you didn't even see that right there, okay? And you see them going -2, -2, then +2, +2. In your head, automatically, should you think, oh, that's going to be a perfectly straight line, or oh, that's going to be a V. V, you know it changes, right? It starts going as a negative slope, and then all of a sudden, what happens? Changes to a positive slope. So could you still look at this graph or look at this table and realize whether it is a absolute value function or a straight line function? Okay, because the slopes right here change if it's absolute value. Yes. Okay. Where does this one cross the y-axis? You bet it still crosses that 1 right here. Nothing changes there. Okay. So the important part here is just knowing and understanding. If it looks like this, you see what I'm circling for the 17th time? If it looks like that, it's going to be what kind of a line? Straight line. If every single number here, you see what I'm circling, is the same number, what kind of line will that table make? Straight. If they have the exact same number, but they start going down and then go up, or vice versa, it's going to be what kind of a line? Absolute value. Okay. Now, let's see what in the world this exponential function is going to look like. Now, another thing we can be pretty obvious about what gives it away one more time that this function, this second function, you see my arrow, is an absolute value function or not a straight line function. It has absolute values in it, right? We know that it's absolute value. We know it's a V. What gives it away that this is a straight line? This other one. It doesn't have absolute values, right? Okay, if it doesn't have anything funky, we know it's a straight line. Okay? So here's what an exponential function looks like with just the letters plugged in right there. So write that. F of x equals a times b with an x above the b. Is this one pretty obvious? It's an exponential function. Why? It has an x. The exponent is an exponential. Yes? Huh. You can see, oh, exponential function. Yeah, that x is an exponent. That's why it's an exponential function. All right? So automatically, should you think, oh, this is going to be a straight line, or should you think, heck no? Heck no, it's not a straight line. We'll worry about drawing the lines tomorrow, but this is not going to be a straight line because what kind of function is it? Exponential. All right? So then you see here where I put A. What does the A represent on this one? Initial value. Okay, so write that. Which I also put what in parentheses. What does an initial value mean? What is this? That's the same thing as the what? Y-intercept. Now that's kind of stupid because on this last one, the absolute value one, what did the A represent here? Sneaking slope. But on this one, we're talking about the A represents what? Initial value. Daggum backwards and all confusing, ain't it? Okay, and then also same thing here. Which letter on the first one, on the linear, which letter represented the slope? Or sorry. Which letter represented the absolute value? The B. But on the stinking exponential function one, the A represents it. Okay, so the letters aren't that important. Just understand the number in front on this exponential function is now the y-intercept, or the initial value. Okay, that's all that means. That's all that represents. Okay, and then obviously put B is the common difference, and we'll talk about what that is as we get rolling. Okay, so our first example, you're going to go ahead and write that one down. That first example would be f of x equals 1 times 2x to the x, 2 to the x. Okay. And again, we're not going to worry about graphing them today. We're going to worry about putting them in charts. So tomorrow, or tables, I guess you'd say. So tomorrow we can graph them. Okay. If you put it in the table, it's really, really easy to graph. All right. Now, to start off, what does that 1 represent? We should already know what that 1 is. What does it tell us? It's in the same place as what letter up there? A. Okay. So the 1 represents the initial value, or in other words, the what? Y-intercept. Yes? So where could I put that 1 in this table right now that represents the y-intercept? Where x is 0, yeah? Boom. We already filled out half of that by just doing that. Okay? Now you don't know what what does 2 represent? What letter did we replace 2 with? B, and B represents the what? Common difference. Well, what in the heck does that mean? Here we go. We're gonna check it out right now. All right. So we're gonna start filling out this chart. How in the world do we do that? Well, if I wanted to figure out what y is right here, this first y, what am I gonna plug in for the x? -2. So how would that work? That would be 1 times 2 to the -2. Here's where some of our rules from last week we spent so long doing. What's the first problem about the problem you see right here? The exponent is negative. Do we like negative exponents? Heck to the no. Therefore, the first thing we're going to do is what? Flip it. We don't flip the 1 because is there a negative exponent on it? No. So we have 1 over 2 squared. I kept the 1 on top and put the 2 on the bottom. Is that too cray-cray? All right, so let's finish that problem. 2 squared is what? 4. So what would that answer be? 1 over 4 or just 4? 1 over 4. So that answer is 1 over 4. Could we write that as a decimal if we wanted to? Anybody know what that decimal is? Yeah, 0.25 or 0.25. Okay, it's better. It's going to be, well, first of all, normally we don't mess with decimals, do we? Well, these exponent ones, you're going to have to, okay? And it's normally easier to write it as a decimal than a fraction. But either way is going to be fine. Both would be the most prettiest. Okay, so the next one, same thing. We're going to replace x with what, though, this time? 1. So we have 1 times 2 to the -1. What's wrong with that problem? Therefore, I flip it. I leave the 1 on top, and I put 2 to the 1 on bottom. Well, what is 2 to the 1? 2. So that answer would be 1/2, which is the same as 0.5. Let's see. Let's check. We already know 0 is 1, but let's just check and see if that's true. If I plug in 0 for 2 right there, or sorry, 0 for x, well, what is 0 or anything to the 0 power right there? 2 to the 0 is what? Remember our rule? Anything to the 0 power always equals 1, and 1 times 1 is? Yay, it worked. Okay? And then in that last, or second to last one, we got 1 times 2 to the 1. Well, that's easy. 2 to the 1 is 1. 1 times 2 gives you 2. And then lastly, 1 times 2 to the 2. 2 times 2 is 4. 4 times 1 is 4. All right. So we filled it out. Was it too crazy to fill that out? Okay, sometimes it's a little bit tough, okay, to figure out what you're supposed to do, but once you start get rolling, you're good to go. Okay, now, this common difference thing, here's the important part. All right, how do I know? Let's say you didn't see anything but this table. Okay, imagine that's all you see right now is this table. Where's across the y-axis, or what's the initial value? By just looking at the table, can you tell? 1. All right, what if I said, hey, is this table a perfectly straight line? Or is it an absolute value function? Or is it an exponential function? Well, to be a perfectly straight line, doesn't every single one of these have to be the exact same number? Well, let's just do these not decimal ones first. The distance between 1 and 2 is what? 1, and the distance between 2 and 4 is what? 2. Are they the same? So since they're not the same, is it any way to be one of these straight line functions from earlier? Okay, since they're not the same also, is there any way it could be one of these absolute value functions? No. Okay, they have to be straight lines. So if they're not, they're obviously what? Exponential. And does it also make exponential means it grows exponentially every single time? Well, does it make sense? It's starting at 0.25 and gets bigger by to 0.5, then it gets to 1, and then 2, and then 4. It keeps getting bigger and bigger and bigger. Yes? How much bigger is it getting every single time? It's doubling, right? Getting 2 times bigger. Like it starts at 1. Let's say we look at 0 here. It starts at 1, and then it gets twice as big. 2 times bigger than 1 is 2. 2 times bigger than 4 is what? Sorry, 2 times bigger than 2 is what? 4. Hence, the common difference. What did they say the common difference was? 2. Well, how do we figure that out? How do we see what the common difference is? How do I erase? All you've got to do is divide. Oh, crap. Is divide. Oops. The bottom one, 0.5, divided by the top, 0.25. Okay? Plug that in your calculator real quick and do that. What do you get? Yay. If we did the second one, 1 divided by 0.5, what does that answer? These other two you should be able to do by yourself. 2 divided by 1 equals 2. 4 divided by 2 equals 2. Okay. The important part is, what did we divide? The one above by the one below, or below from the one above? You see the difference there? And make sure you write that out. Okay, for this example right here. Make sure you write, to find the common difference, you do the bottom one divided by the top one. Now, do you think if any of these were different, if any of those were different, would we have a problem with this? What do you think? Yeah, we'd have a problem. Okay, so if you ever run into that where they're not the same, we obviously have a problem. It's just like anything else. It has to be consistent. It has to grow 2 times bigger every single time. Okay, so do we know how to get that common difference right there? We divide. Yes, we divide. What does the A represent? Where it crosses what? Y-axis. Another name for the y-intercept is what? Initial value is going to be important. Okay, and then the common difference, that's basically pretty similar to what in all these other problems we've been doing? Well, we have a slope, we have a y-intercept and a slope on about all of these, yes? It's pretty similar to the slope. But think about this, the slope tells you how steep something is, yes? When you have a curved line, which what we're fixing to do, is there really going to be a slope to that line? No. Okay, so they, instead of calling it a slope, they call it a common difference, because the slope is always steady and true, right? Okay, common difference is never steady and true, so they just call it a different word. All right, so today they're going to give you a table that looks very similar to this, only exactly the same, and they're going to tell you, hey, write it in this form. So I want you to go ahead and write these first. Actually, this first one we won't write down, and the last two we will. Okay, so we have a couple examples in our book. We want to write it in this form, right here. So we got to put a number in for A, and we got to put a number in for B. Well, the A is really, really easy. What number are we going to put in for A? 2, because it's the what? Y-intercept. Boom. So if we're doing that one, f of x equals 2, simple, times B. B represents that common difference, right? So I've got to divide Which one? 0.4 by 0.08 or 0.08 by 4? Now, if you know they're exponential functions, would it be better to divide these decimal ones or them easy numbers up down below? Do the ones down below. Go ahead and do 0.4 divided by 0.08. What do you get? 5. Well, down here, if we do these easy ones, what's 50 divided by 10? Oh, that was easier to do that. 10 divided by 2. 5. So what would be my common difference on this sucker? 5. So we got to find two things. The y-intercept, which another name for the y-intercept is what? Initial value, and the common difference, which is the b. Can we find the common difference? That's only the hard one, and is it really that hard? All right, so write down this second one so you actually have an example and you can see what you're doing here. Okay, and when you do it, I want you to circle this one. Why do I want you to circle that one? It's the y-intercept, and I want you to put a little arrow going to it somehow, okay, and identify it as the y-intercept, just as I have. So you know how to find the y-intercept when you come back and look in your notes. So where do I put that 9? Where the A goes or where the B goes? Where the A goes. Every single time, all the time. How do I find the B? Bottom by the top. Here we go. So let's start with these easy numbers down here. This is important. 1 divided by 3. Not 3 divided by 1. 1 divided by 3. What do you get when you divide 1 divided by 3? 0.3333. Now stop. Okay, I want that. Well, let's do another one. Get 0.333333. Does anybody know what that is at the fraction, first of all? Don't think too hard. 1 divided by 3. Couldn't you write 1 divided by 3 just like that? Okay, so that's the fraction. Go ahead and do 9 and 27 just to make sure it's still 0.333. 9 divided by 27. Hopefully it is. And if it is, we're good. Okay, 9 divided by 27 is still 0.33333. So make sure I didn't do it, I'm sorry. But make sure you literally put 9 divided by 27. Okay, do a couple of these over here. 1 divided by 3. Okay, and name it common difference. So you know exactly what you're doing to find the common difference. What do you think they want it written as? A decimal or a fraction? They want it written as a fraction, okay? They want it written as a fraction, especially when it's a irrational number because it doesn't 0.3333333 never end. So they want it written as a fraction. If you have trouble figuring out what the fraction is, one, if you put it in math print in your calculator, it'll tell you, okay? Or just ask me, okay, if you're not sure what the fraction would be. Okay, but this one literally tells you 1 divided by 3 is simply 1 divided by 3, right? Or you have 9 over 27. If you reduce 9 over 27, what does it reduce to? 9 goes into both of those. 9 divided by 9 is 1. 27 divided minus 3 is 3. So what am I going to put in place of the B since we finally got that? 1 over 3. And a lot of times they put parentheses around the B's. You don't have to. I'm doing it just here just so you see that. And make sure you always put the X up there. Don't forget about your little exponent X. We haven't done anything with the exponent X just yet. Make sure you always put it. Okay? Do we need to put another example in our notes? I don't think we do. If you really want to, you can put that one in there. But let's do it real quick. What am I going to put in place of A? Huh? 3. Easy peasy. Okay, the common difference. To find the common difference, I got to do what to these numbers? Divide. So let's do this easy one. 12 divided by 3 is what? 4. So let's just do one more just to double check. let's do the decimal one. Someone do that one for me. 0.75 divided by 0.1875. It's 4. So what am I going to put in place of b? 4. Okay. Notice, does that look good? 3, 4 to the x? Make sure you put a time sign or a parentheses there to split those. Because if you just put 3, 4, I think it's 34, right? You can put a parentheses. You can make it look like this. I don't care. But that's how you do. That's all we're doing today. Can we plug in A? Can we plug in B on these functions? Then let's do it. Not today. They'll be different, but they can be any way you want. We'll talk more about that tomorrow. So problem number 1, or first of all, the page number is 229. 229 page. 7, 8. 7, 8, 21, 22, 24, 25. I don't know, it's fun. 26, 28, 31. Okay, as you're going, is everybody listening to me? You do the directions as the directions say, which on all of those, literally all it says is write the function, okay? But you see the ones in parentheses right there? Okay, there's more than one part to those. The only part we're doing is writing the function. Okay, so it'll tell you to do some other stuff. We're just writing the function on those, and tomorrow we're going to answer the rest of those. Okay, so the ones in parentheses, yeah, you can read the question, but you're just doing the easy part, writing the function. Okay, 1, 2, 3, rock and roll in this thing.